covering 6.5. So 6.5 is going to deal with square root and cube root functions. So let's talk a little bit about what those even are before we get into anything dealing with them. A square root function is, the parent function is just going to be the square root of x, and a cube root function is going to be the cube root of x, okay? With a square root function, we do have a limitation on the domain, okay, with square root functions, and that's because you can't take square roots of negative numbers. Now, we have a workaround called imaginary numbers, but when we're graphing, in this class at least, we're graphing in the real number situation. We're not dealing with imaginary, okay? So don't pretend we don't have those. Can you take the square root of a negative number without using an imaginary number? No. So for that reason, we can only take square roots of 0, anything 0 or bigger than that, right? So whatever value is going to make what's underneath the radical less than 0, we have to exclude from our domain, okay? And the range we can find by just plugging the lowest value of the domain into the function to get the range. So this is what the square root parent function looks like. We're going to talk about how we can kind of produce that. But yeah. Oh yeah, you're good. I don't think I'm charging over there if you want to plug it in over there. Alright, so this right here is going to be a format that you see a lot in this class. You've already seen it, the A, H, and K format. The A determines vertical stretch, vertical compression, and vertical reflection. The H represents left and right shifts, horizontal, and the K is vertical up and down shifts, right? So remember, H is always opposite. Y'all remember that from yesterday or whenever? Okay. So let's go ahead and define what each of those things means and how it affects the graph. So a negative A, when your A is negative, that's a reflection over the x-axis. Now, not only does A determine reflections, but A also deals with vertical stretch and vertical compression, right? So what we have to do is, if our A is negative, we have to take the absolute value of it to determine what type of thing that's going to be. So if your A value is between 0 and 1, is that going to be a stretch or a compression? A compression. So this right here is a vertical compression. And if your A value is greater than 1, that's going to be a vertical, vertical stretch. Okay. Oh, I'm writing shift, I don't mean that. We're going to get to that later, not yet. This is taking forever. I hate how there's not like a eraser on this thing. Okay. So we talked about H. We know that H is always the opposite, right? So if it's going to be a negative H, that means we're going to be going to the, yes. And if it's a positive H, we're going to shift left. And then K is just as it is, okay? K is very easy, it's straightforward. If it's a negative K, it's going to be, yep. And if it's positive K, it's going to be, good. Okay. So let's talk a little bit about how these things affect the graph, okay? So let's talk about A. So if my A is negative, first thing I'm going to do, I'm going to just sketch the square root parent function. Okay, that's what the parent function looks like. So this right here is just the basic one. Now in the green pen, if my A is going to be negative, it's going to reflect me over the x-axis, okay? If my A is bigger than, or the absolute value of it is bigger than 1, it's going to stretch it out. It's going to get taller, right? So this is if my A is bigger than 1. And what if my A, sorry, I got to change my color palette here. What if my A is a little number, like 1/2? Yeah, it's going to get more shrunken down. Okay, that's if A is a little number, all right? So that's what A does. Now H. So if my h is negative, it's going to shift it this direction, right? If my h is negative, it's going to go to the right. And if my h is positive, it's going to go to the left. And what about k? If k is positive, it's going to move it up. And if it's negative, it's going to move it down. So the main thing you need to know is that A and K are vertical. They affect f of x, okay? And H is horizontal, and it affects what? Good. And you all know f of x is the same thing as y. So if we refer to it as y, we're talking about the same thing. So this I know isn't really like useful kind of to look back on, but it kind of helps you just understand as we go through it. Okay? And the rules down here are the same, so you can copy them down again if you want, but it's the same idea for a cube root function. So a cube root function, parent function, looks like this. We're going to talk about how we can generate that in a minute, but let's talk about how it's affected by the different types of interpretations. So if it's reflected over the x-axis, it looks like this, right? That's when A is negative. When my A is bigger than 1, it's going to get stretched out, right? So that's when A is positive. If my H value is positive, it's going to shift it to this direction, right? What about if my H is negative? Shift it to the right. And then K, if K is negative, it's going to go down. And if K is positive, it's going to go up. So that's just like a little bit of an idea of what's happening as we deal with this. So I know it's hard to kind of read, but it just helps to write it out so you guys have seen everything. What? All right, everybody ready to actually do some transformation? Sure. Okay. No. It just looks a lot, yeah. All right. So we're going to talk about how we can, yes.
Are these the same rules from yesterday?
Yeah. So now we're going to talk about how we use the table method to graph, okay? So the table method is where you basically use a table to generate values, okay? So this right here is the quadratic parent function. Now the table that we generate right now is going to be the table that we use for every time we have a square root parent function, this table right here. And you're going to realize why we picked these values. So you're going to plug these values into the function. What would be the square root of 0? What's the square root of 1? Square root of 4? So do you see why we picked 0, 1, and 4? Because they're all perfect squares. So you don't want to pick, you could pick 2, but you're going to get a decimal. You know what I mean? So we try to pick values that are going to come out nicely for our table. So once you have that, this is what the square root parent function looks like. So the square root parent function is like a ray from geometry. Why is it more like a ray than a line? Yeah, one end is finite and one end is infinite, right? Like a ray. So keep that in mind with square roots. That's going to affect the domain and range. Because if something is not infinite on one side, one of my ends of my range and domain are going to be finite, okay? So my domain, my function starts at 0, and then it goes to positive infinity, right? So if we're talking about x's, the smallest x it's ever going to take on is 0, and then it goes off to the positive infinity direction. Now, to generate your range, you're going to take the lowest value of your domain and plug it into the function. So what's the square root of 0? Good, so my range is also 0 to positive infinity. Now, you haven't done an end behavior problem that works with something that has a finite end. Okay, so it's a little bit different. Does x ever approach negative infinity? No. What's the smallest it's ever going to get?
0.
Good. And when it gets that small, what is its output y value?
0.
Also 0. As x goes to the positive infinity direction, is my function going up or down? Up to positive infinity. So it might be hard to see right now, but you could plug in more points to get this idea. It's actually going up, it just does so very slowly. So like if you kept going, what's it going to, at the x value of 9, the function's going to be at 3. Good. At the x value of 16, it's going to be at 4. So you see how it's going to get bigger, it just does so very, very slowly. So that's the general idea. Alright, so we're going to use this table again in the future. So now we're going to look at the cube root parent function. So we're going to do the same thing here, but we're going to plug it into the cube root function. So what is the cube root of negative 8? Negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. What's the cube root of negative 1? Cube root of 0, cube root of 1, and cube root of 8. So remember, odd index roots you can take negatives of, just not even ones, because you can't have two different numbers, because to get a negative number you need to have an odd number of negative numbers multiplied together. So now we're going to plot those. And you're going to end up with something that looks like this. Now, if you were to kind of flip your paper to the side, this is going to look really similar to another type of function we dealt with, a cubic function. You remember back when we did polynomials with the two turning points? You had the graphing calculator. If you turn it on the side, it looks like a cubic polynomial, right? That's because it is the inverse of a cubic, because it's just tipped on its side, okay? And what you might notice is this looks a lot like a quadratic, only half of it, right? Yeah, same idea. Alright, so this function actually is going up. It might be hard to see, but if you kept getting values, like if you tried taking the cube root of 27, it would be at 3. It just, once again, goes really slowly. The thing about cube root functions is they have all real numbers for the domain and the range. Why is that the case except, like, as opposed to the square root one? Good, to infinite ends. And the end behavior is the same way. So as our x values get smaller, so do my function values. It's going down. And as my x values get bigger, so does my function value. It's going up as well. So any questions about the parent function? All right. So now we're going to talk about how we can deal with transformations. So you're going to notice on your homework, I'm not going to write the tables out for you. You're welcome to use the tables. You just got to sketch your own table, okay? So what you're always going to do is, notice that this is a type of square root function. I see that it's not a cube root. It doesn't have a 3 on the index. So here's what you're going to do. You're going to take the original square root table that we just generated, and we're going to manipulate it based on the types of transformations we have. So let's look at this and describe the transformations. This right here indicates that I have a vertical stretch of 2. Do I also have a vertical reflection, yes or no? No, because the a value is not good. We also have another vertical transformation. We go, you're right, we do go right 1, but we also go down 3, and then we go right 1. Okay. So once you've identified all the types of transformations, we have to determine which ones of these are occurring on the vertical and which ones are occurring horizontally. So this is a vertical, this is a vertical. We know that vertical affect the y values. We know that horizontal affect the x values. So that's the portion of the table that they're going to affect. So if we're shifting to the right 1 unit, what's going to happen to all of the original x's? They're going to increase by 1. So you're going to take your x's and you're going to add 1 to all of them. So 0 plus 1, 1 plus 1, and 4 plus 1. Now, with the one in the yellow, it's a little bit different. We have a vertical stretch, which multiplies your values, and then we also shift down. So if you think of order of operations, do you multiply or subtract first? Same rule applies here. So you're going to take your y values, you're going to multiply them by your vertical stretch. If your vertical stretch was negative, you're still going to keep it negative as well. So if it were like negative 2, you'd multiply it by negative 2. And then you're going to either add or subtract your vertical shift. This one is subtraction because it's down, okay? So we're going to apply this rule to all of the y values. So you're going to multiply them by 2 and then subtract 3. So 0 times 2, 0 minus 3, good. 1 times 2, 2 minus 3, good. 2 times 2, 4 minus 3, 1. So now you're going to plot your new transformed function. So 1, 2, 2, oh, I did something wrong. I was like, wait, that's not right. Sorry. Okay. I was looking at the wrong thing. 1, negative 3, 2, negative 1, and 5, 1. And that's what it looks like. As you can see, it's been vertically stretched. It's also been shifted to the right 1 unit, and then it's been shifted down 3 units as well. So we have to adapt our domain accordingly. So let's think about this real quick. What would happen if I had plugged in 0 into my function? 0 minus 1 is? Could you take the square root of that? No. So the smallest possible value I could have plugged into this is 1. So my domain is from 1 to positive infinity, because the lowest my x ever is going to go is 1 right here. And then your range is going to be corresponding to your domain. So when my domain value is at 1, the range value is at negative 3. And it's also going to go up forever. And that's always going to correspond to, if you do your table correctly, of course, that's going to correspond to this right here. See that? Yes.
So why would the domain be 1 again? Because there's a point at 0, right?
We're talking about the one in the purple, not to be
Okay.
confused with the original. So end behavior, does x ever approach negative infinity? The closest it's going to get to that is regular 1. And as it's at 1, the function's at negative 3. And then it goes to the positive infinity direction for both. It's going up and up over here. Up and to the right. So any questions about that one? All right. And every time you do one of these, you're going to use this table right here. That's the standard table. So for the next one, we're going to do a cube root example. So let's describe the transformation. It has a vertical, good, another vertical stretch of 2. It goes down 4, and it goes left 1. Now we know that these two right here affect the, which part of the table? The y. And this one affects the x. Good. So I'm going to take all my x's and I'm going to do what with them? Minus 1. Because remember, you're going left. So think about it. Go left, you're going to subtract. So that's going to be negative 9, negative 2, negative 1, 0, and 7. I just took all the x's and I subtracted 1 from them. Now for the f of x rule, you're always going to apply your vertical stretch, compression, or reflection first. So we're going to take that and multiply it by our values, and then we're going to then subtract the 4. So you're going to take each one of them, multiply by 2, and then subtract 4. So that's going to be -8. Next one is going to be -6. -2. Is that right?
Wait, how did you get -2?
I messed it up, didn't I?
It's -4.
You're right. I was looking at this value. I shouldn't have done that. Sorry. Negative. Yeah, that's -6. Okay. And then the next one, I multiply this by 2 and subtract 4. Multiply by 2, subtract 4. Does that look right?
Yeah.
I don't know. It feels off. Let me just double check.
Isn't a negative times negative a positive and
Yes.
I don't know that.
like the first one, -8 before something.
What?
You're
Well,
doing
-2
-2
times
times, so negative
oh, it's regular
multiply.
2 then.
It's okay. I was getting confused too. Okay. So let's go ahead and plot it. That will tell us if it's right, because it'll look funky if it's not. -9, -8. That's the good thing about it, is you can usually tell if it's wrong just by plotting it. It's not going to look right. You'll know. Looks good to me. You see how it still has the same shape as the other one? It's just kind of manipulated a little bit. So it should look something like that. As you can see, it's been vertically stretched and shifted. So here's the exciting thing about cube root functions, is the domain and range are always the same. And then you do have to be careful about end behavior. It's going to go infinitely on both directions, but you have to make sure if it was flipped around, you don't have to draw this, but if it was something like this, that's going to change going in the negative direction, positive direction. Just be careful. Make sure you read the graph. So as our function goes to the right, it's actually going downward. I'm sorry, as it goes to the left, it's going downward. And as it goes to the right, it's going upward. It's hard to see because it's very gradual. All right, I'm going to go ahead and hand out your homework. Like I said, you do